You know, usually when we talk about building something like a house, let's say, you think about the massive structural elements.
Right, the foundation. The load-bearing walls.
Exactly.
Yeah.
You obsess over the architecture, the blueprints, but once you actually move in, the thing that drives you to the absolute brink of insanity on a daily basis, it isn't the foundation.
No, it's a squeaky door hinge.
Yes. Every single time you walk into the kitchen,
Yeah.
you can have the most beautiful, structurally sound house in the world. But if that door squeaks every time you open it, I mean, that is the only thing you are going to think about.
It's those micro frictions. We build these incredibly complex systems, whether it's a physical building or, a sprawling software architecture. But our actual lived experience within those systems is entirely dictated by the tiny, repetitive interactions.
Yeah, we tolerate them for a while.
We do. We tell ourselves it's just a minor annoyance. But eventually, those micro frictions, they compound and they just completely shatter our concentration.
Okay, let's unpack this, because today we're diving into a highly specific set of developer notes. These were published back on April 30th, 2026 by a developer named Ang.
And this is a really fascinating deep dive.
It is. Because Ang hit a friction point so intensely annoying that it didn't just lead to like a minor software update. It sparked a massive realization about how we communicate complex logic.
And I should say up front, you do not need to be actively writing Haskell to see the value here.
Right.
The notes Ang wrote are technically about implementing a cross-platform autofile opening feature for a text-to-PDF ebook generator. But beneath the code, it's really a masterclass in human psychology.
It's totally about how we interact with the tools we build. I mean, every great philosophical realization usually starts with someone just trying to get their work done, right?
Absolutely.
So for Ang, the annoyance was the testing loop. When you're building a tool that generates PDFs from raw text, you have to test it constantly. You create the text, you compile the program, it generates a PDF.
The program just stops.
Right. The generation is finished, but the evaluation hasn't even started.
Yeah, to actually see if the code worked, Ang had to manually leave the terminal, open up the computer's file system, navigate to the specific output folder,
Visually scan for the newly created PDF.
and double-click it to check the formatting. Generate, navigate, find, open, review, and then go back to the code and do it all again.
It's exhausting just saying it. So Ang decides to build a bridge. The goal is to have the program automatically open the generated ebook using the operating system's default viewer, like the exact millisecond the conversion finishes.
Which makes sense.
But this isn't just flipping a switch. To make this happen, Ang has to bridge the isolated Haskell application with the computer's deep operating system.
Yeah, it requires a lot of architectural plumbing under the hood.
So Ang is in there adding the process package to the project dependencies in the package.yaml file, importing modules like system.process to use call process, and even adding an open after Boolean to the arg's data type.
It's a significant amount of work. You're hooking into the underlying operating system just to trigger an event that the user could technically do themselves in about 3 seconds.
Wait. So this is like inventing a toaster that not only toasts the bread, but like perfectly drops it onto a plate in front of you.
That's actually a pretty good analogy.
Right. It seems minor, but eliminating that manual step changes the whole experience.
But I gotta push back a little here. Is it really worth modifying the core code and adding new dependencies just to save a single double click? I mean, that sounds like classic developer procrastination.
What's fascinating here is that if we were purely measuring physical time, probably not. But what Ang is optimizing for isn't time, it's cognitive resources.
Oh, interesting.
Yeah, when you are deep into complex logic, you operate in a flow state. Your brain is actively holding this massive, fragile architecture of variables, logic branches, dependencies, all in its working memory.
So any interruption is dangerous. Exactly. The moment you are forced to switch contexts, when you have to stop thinking about abstract logic and start visually scanning a crowded desktop for a PDF icon, that fragile mental architecture just collapses.
Oh, I get that. If you've ever been like deep into writing a research report, holding 3 different arguments in your head, and you have to stop to go dig through your downloads folder for a source document.
You lose the thread entirely.
By the time you find the document, you've completely forgotten what you're about to write. It's the cognitive cost of shifting gears.
Precisely. And rebuilding that mental state takes immense energy. So by automating the file opening, Ang is protecting that flow state. The feedback loop, from writing the logic to seeing the visual result, it happens seamlessly.
So the machine handles the mundane context switch, which lets the human brain remain entirely focused on the complex problem.
Right. But, and this is a big but, this friction of switching context doesn't just vanish once you automate the task.
It doesn't.
No, it actually just transfers the burden over to the interface design. Because now that this auto-open capability exists, Ang has to give the user a way to actually trigger it.
Right. And for a command line interface tool, you trigger optional features using flags. So Ang wires up the flag -- open.
Right. If you append that to your command, the program knows to launch the PDF afterward.
But obviously, users expect a shorthand. Nobody wants to type out the whole word every time. They want a single character flag.
And here's where it gets complicated. The natural mapping for the word open is -O.
-O. Yeah, that is the intuitive leap anyone's brain would make. But, and here's where it gets really interesting. There's a massive collision here.
Oh, a huge one.
In the broader ecosystem of command line tools, -O is almost universally understood by programmers to mean -- output. It's how you explicitly set the output file name.
It is deeply ingrained muscle memory.
It's crazy. I mean, we have these highly advanced machines, and we're literally limited by the 26 letters of the alphabet. How do developers map these flags to a user's mental model when the logical letter is already taken?
Well, this is where software development becomes essentially a study in behavioral psychology. Building tools isn't just about code, it's about predicting human behavior and logical associations.
So if -O is taken for output, what did Ang do?
Ang realizes that finding an alternative letter usually leads to unintuitive, arbitrary shortcuts. I mean, do you use -P -X? The moment you choose a letter that doesn't logically map to the action in the user's mind, you destroy memory retention.
Because now it's an exception. And exceptions require active memorization. If I'm using the tool and I try to guess the flag,
Yeah.
I'll probably guess -O, right?
And it will fail, or worse, overwrite something.
Exactly. And then my flow state is broken because I have to go open the documentation to look up your weird, arbitrary shortcut. You've solved the friction of the double click, but you've engineered a new friction point right at the interface.
That's it, exactly. A user's mental model relies on predictable patterns. Unintuitive shortcuts destroy that. When you force a compromise because of an arbitrary interface limitation like running out of letters, you shift the cognitive burden right back onto the user.
That is such a wild trade-off to have to navigate.
It really is. Ang's notes brilliantly highlight how these external constraints force developers into uncomfortable positions. But it doesn't stop at the external user interface.
Right, because after wrestling with the flag, Ang dives into writing the internal logic. And instantly they face another choice: how to structure the flow of the program without creating a tangled mess.
Yeah, when you have optional logic like executing a command only if the user passed that specific flag, the default architectural reflex is an if-then-else block.
Sure, if the flag is present, launch the process, else do nothing.
Exactly. It's foundational control flow. But Ang explicitly avoids it. Instead of using standard if-then-else blocks, Ang utilizes a utility function called when from the control.monad module.
The control.monad module.
Mm-hmm.
Okay. And the specific reasoning Ang gives is that using when allows the code to execute the conditional logic while entirely skipping the else boilerplate.
Right. Which, functionally, is identical to an if-then-else where the else does nothing. But structurally, it is vastly different. An else block that performs no action is pure boilerplate. It's syntax that satisfies the compiler but provides zero value to the logic.
So what does this all mean for the code? Because it sounds to me like cleaning out a cluttered closet, right? Getting rid of the else block is like throwing away the clothes you never wear so you can actually see what you have.
That's a great way to look at it.
But does skipping the else block really make that big of a difference? We're talking about saving what? A couple of words.
If we connect this to the bigger picture, it isn't about the vertical lines of text. It's about the horizontal indentation.
Oh, the spacing.
Yes. Every time you introduce an if-then-else block, the code enclosed within it is indented. If you have multiple conditions, the code pushes further and further to the right. It creates this wedge shape on the screen.
And our eyes don't process code like we process a novel, right? We don't read every word left to right. We scan it.
Exactly. Nested code becomes a cognitive maze. Every indentation represents a new branching path, a new hypothetical state that your working memory has to maintain. Every indentation is another thing the brain has to hold.
Wow. So by utilizing when to strip out the empty else branches, Ang keeps the structure flat. It reads linearly.
You aren't forcing the maintainer to hold a complex decision tree in their head. You're just presenting a straightforward list of conditional actions.
And this intense focus on making the code visually clean and readable It triggers kind of an aha moment for Ang because it forces them to confront a massive cultural divide within the Haskell programming community itself.
Oh, the Great Divide. Yes. Haskell is a fascinating language because its roots are deeply embedded in mathematics and academic research. It allows for highly expressive, incredibly terse logic.
Right.
But as Aang points out, that capability has fractured the community into two distinct stylistic camps, academic Haskell and industrial Haskell.
Right, and Ang outlines this stark stylistic contrast. The academic style focuses on extreme brevity. Ang actually calls it alphabet soup.
It really
It
is.
uses long chains of the $ operator and cryptic functions like flest and send. And Ang discusses the initial attempt at writing the operating system matching logic using those functions, just blindly extracting elements from tuples.
In an academic style, you don't declare what the data is. You just perform a sequence of mathematical extractions on it. You chain it all into a single, dense line of code. It's optimizing for the absolute minimum number of characters on the screen.
So it's highly efficient for the compiler, but when a human looks at it, they have to manually uncompress all that chained logic in their head just to understand what's happening.
Yes. Which brings us to the industrial style. Ang notes a conscious, deliberate shift toward this methodology. Industrial Haskell abandons the pursuit of clever brevity. It favors explicit naming conventions.
So instead of obscure functions, it uses multiple let blocks for clarity.
Exactly. It relies heavily on clear pattern matching, where you visually map out the shape of the data structure right in the code rather than blindly extracting from it.
And Ang explicitly chooses the industrial mindset, rewriting the code so the logic is easier to digest. They note the satisfaction of a clear output, specifically highlighting the line, where underscore arrow do put Dependencies conversion successful.
Yes. It isn't buried in a mathematical chain. It states its intent clearly and sequentially.
I absolutely love this divide. It's like the difference between a dense, brilliant poem that takes hours to decode, that's the academic style, versus a highly detailed, step-by-step instruction manual that anyone can follow. That's industrial.
That's a perfect analogy.
But here's my question. Isn't the academic way technically more elegant if it uses less code? Like, why write bulkier code if you don't have to?
This raises an important question, and it comes back to the core realization Ang arrives at. Code is executed by machines, but it is maintained by humans.
Maintained by humans. Right.
A machine parses a dense, single-line chain of operators with the exact same efficiency as it parses a clearly named, well-structured function block. The compiler doesn't care.
It just reads the instructions.
Exactly. The shift to industrial code proves that empathy for the next reader, or, yourself in 6 months, is vastly more important than showing off how few characters you can use.
So true. If you write that dense poem of code today, you're going to spend 3 hours trying to decipher your own genius when a bug pops up later.
Precisely. If a junior developer cannot look at your logic and immediately understand the control flow, your brilliant brevity has actually become a liability to the project.
What a journey. Just quickly synthesizing this for you listening right now. We started with the simple desire to automatically open a PDF ebook, which led us into the UX crisis of command line alphabet limits.
Yep, the struggle for Dasho.
Right. And then the cognitive load of nested else statements. And finally, a philosophical choice to write industrial code that prioritizes human understanding over academic brevity.
It's all connected by that one theme, cognitive load.
Completely. And whether you are coding a Haskell application or writing a company memo or just sending an email, clarity is a gift you give to your reader. Empathy is the ultimate optimization.
It really is. The human mind is the bottleneck, so design for it.
Exactly. But I do want to leave you with one final lingering concept to mull over, building on what we've talked about today.
Okay, let's hear it.
If industrial programming relies on explicit human-readable naming, because our attention is the real bottleneck, what happens as artificial intelligence begins to write and maintain more of our software?
Oh, wow.
Right. Will human readability even matter in the future? Or will our code bases revert to an entirely new, alien kind of alphabet soup that only machines can understand?
That is a fascinating thought, because if the human maintainer is removed from the loop, the need for empathy goes right out the window with them.
Something to think about next time you hit a squeaky hinge in your workflow. Thank you for joining us on this deep dive. Keep learning, stay curious, and we will catch you on the next one.